Welcome everyone. I hope you've been enjoying the event and managed to get something tasty to eat for lunch. Now, our next speaker is Trent Jones. His talk is going to be about architecture for all. Trent from AI Media has been designing, building and testing software for over 10 years across a wide variety of industries. He has a passion for DevOps and inclusive software, along with a lifelong love of sharing and learning. Over to Trent.
Thank you everyone for joining me today. So this is a little talk I've been developing across a number of different engagements. In my previous life I was a consultant, so I did a lot of architecture diagramming and the various likes. So thank you for joining me. First off, thank you to all the sponsors. Today wouldn't be possible without them all, so it's really appreciated. I know they rock up year after year, so yeah, really appreciate them. So I thought I'd start off with a quote. Architecture represents the significant design decisions that shape a system where significant is measured by the cost of change. And the really important part here for me is that last part of the sentence. Significant is measured by the cost of change. These decisions in your architecture diagrams, in your architecture, they have a cost associated with them. Changing them is not as simple as just swapping a component out. Generally speaking, maybe you've got microservices and it is easy, but generally speaking, they're quite complex tasks. So I really like that quote. It's a great setting. Onto diagrams. Who's audience participation? Who's done a diagram before? Who's done an architecture one? Nice. How many of you have done it on a whiteboard? Mostly on a whiteboard, yeah? How many have done like more professional, used a bit of software and had to store it in the system where everyone references? Cool. So we're all pretty familiar with architecture diagrams then. So some examples. This one, lots of boxes, barely any labels. There's a bunch of arrows in the middle there that are so close together you can't even see where they're going. I'm probably guilty of doing this at some point in time. There's been some complex systems in the past. But overall, you don't get a great picture of what's going on here. There's lots of pretty colours and a few arrows, but not much else to really tell you what this system does or how it behaves. What about this one? Same sort of thing. It's a little bit more spread out, so it's got that going for it. Bit better use of colours, objectively, maybe, perhaps. Few more labels, again, perhaps. There's actually a label on one of the arrows there, which may or may not be useful to you. But at the end of the day, it's still kind of difficult to see what's going on with this architecture diagram. And then lastly, I have this pretty whiteboard drawing. This is probably, honestly, the best out of all of them. It's even got some users in there down the bottom in green. Lots of the arrows and the data flow is actually labelled. But yeah, they're all, at the end of the day, they're all just boxes. That's boring. What the hell are these, what are these actual components? Is it like an EC2 box running Java Spring Boot, or is it a Lambda microservice? Like, what's actually going on in this architecture? Who knows? So stop it. Don't do it anymore. Don't like it. This is a slide that I didn't delete when I was meant to, so let's skip that one. My purging last night clearly missed a slide. So I wanted to talk through a scenario because I thought that was the best way to kind of illustrate how we might go about designing better architecture diagrams. So I came up with a cannery. Don't ask me why, my brain works in weird ways. So products are randomly sampled as they go along the conveyor belt. They're tested for anomalies, and we take some action. All right, so there's something that does that random sampling. There's something that detects that random sample event and actually makes a change in the system. We have to do something to take that sample from the product. And then we get results back. We get a pass or fail from that sample. And again, we have to take action if it fails. If it's good, then we continue doing whatever it is a cannery does and we profit, hopefully. So this is a plausible architecture, right? It's not a good one. I'll give you that. But it's a plausible architecture. We have a sensor. It's sending some sort of data to a sampling engine. There we have a pretty box. The box I said don't do, because boxes are not good. If the sample fails, it goes around to a staff member. Don't know what sort of staff member. Is it the cleaner, or is it the manager? Like, who are we actually sending that to? Is it the CEO that gets the message? And then the staff member sends something back to the sensor. What are they sending back to the sensor? There's not a lot of information going on here, but I can almost guarantee that there's architecture diagrams like this out in the wild. So all we can really tell from this with any great certainty is that when we get sample results back, we do something with those sample results, right? We could see those data flow labels, the sample passed and sample failed. That's the only real certainty we can get out of this architecture diagram. So let's iterate. So now we have a production line. We can see what's actually happening here. From the production line, there's two-way data flow between the random sample sensor, which has a better name now, by the way. It's not just a sensor, it's a random sample sensor. We've got really descriptive labels associated with these things. The random sample sensor, we still don't know what it's doing. It's just passing something into a black box sampling engine. We still don't know what that sampling engine does. We can see when it passes, we actually go and restart or continue the production line. That label might need some work. And we can see the manager at some point presses the start button, but we don't really know when that is. So, arguably better, maybe worse. Hopefully it illustrates a point though. So now we can see that we've got something generating a sample event. We know a bit more about what's happening in this system from this. There's probably a few other bullet points we could include there. We know that it's running against a production line. We know that it's a manager that takes action on this system. Overall, we're starting to get a better picture of what this whole system does. But we can do better. So, let's try. So now, we have a lot more going on here. I'll try to run through it really quickly for you. Of key note is we no longer have that black box sampling engine, right? We have individual components. We have an SQS queue. We have a Lambda that takes the sample and does something with it. We have we can see that the sample goes through some sort of analyzing system. Don't know what. I'm not a canary manager, so don't ask me. And then it gets processed by another Lambda. So we know instead of that single black box that we thought we had, we actually have 3, arguably 4 different components there, which is massive amounts more information that we can convey to our users, our stakeholders, anyone who's interested in this system. Brand new devs that join the team. You can go, oh yeah, cool, we work with 2 Lambdas and an SQS queue instead of just there's this black box and you'll eventually figure out what it does. There's tons more information here. We can see when it fails, we actually send a notification to the manager. It doesn't just nebulously somehow get to the manager, who then analyzes the results. And there's some subjectivity here, clearly, because otherwise we wouldn't need to analyze the results. The manager probably wouldn't even need to be involved. And then you can see that based on analysing the results, they'll restart the production line. Perhaps there's other steps they have to take before they can do that. I would assume they have to remove the crappy product before they restart it. Again, I don't actually know how canneries work. But that's the basic premise, right? We want to convey exactly what's happening in this system. Clear labels for everything. Your components, it's not just a Lambda, it's a Lambda that takes a sample, it's a Lambda that processes sample results. It's very clear what those individual components are doing. And that then helps you to convey meaning to the rest of the people involved in the project. So this is a real world example. This is something that I used at a client. This is actually part of a smaller part of a larger architecture. So this is one component out of 4, 6. There was multiple VPCs, peering going on, and it was all illustrated in the diagram. I used a little pipe symbol to indicate that there was peering between the various VPCs. Use your imagination here. Use something descriptive that's not just a box and an arrow to get your point across. In this particular case, we're talking about a step function. You can see we're using the diamonds to indicate decision points in the process. The grey box, I'm hoping it's grey on my screen, the bit in the middle there, with the map states is actually a parallel state where it takes multiple results and spins up multiple lambdas concurrently. Not sure that's the best representation, but at least it gets the point across that something different is happening at that particular part of the process, which is the goal here, is we want to communicate exactly what's happening. And you can start a discussion around that point. You can go, hey, product owner, we're actually spinning up 20 lambdas here, right? This is very different to just spinning up one lambda. They're all processing things concurrently, and we have to take certain actions as a result. Down the bottom, you've got external integrations with Mulesoft. That's as far as I went with this particular diagram. You could go further. The Mulesoft actually pointed at SAP. Whether that adds value or not is up to you. The one thing this doesn't include is people. That said, this system doesn't actually really have people in the process. It's a fully automated system. So perhaps not the best example, but I thought it would be interesting to include a more beefier example of what I'm trying to get across here. Cool. I'm going really quick, of course. So, look, you see, really quick. That's basically the end of my talk. So, the key takeaways here are build architecture, design architecture that includes everyone. Don't build these little black boxes that only the technical experts understand. You lose so much value. Your POs, they don't know what's going on with these little black boxes. You tell them there's a Lambda that's doing something, instantly they go, oh, cool, I actually understand what that is. You might have to explain to them how a Lambda works, but they're going to feel more connected to the project. They're going to be more interested in what's happening. I've seen it time and time again. The good POs, even the mediocre POs, they are way more involved in the process if you encourage them and include them in the whole thing. They want to be involved in this. At the end of the day, that's their product, right? They want to know what's happening with their product. They are the owners. So really encourage them to get involved in this process and build a diagram that does encourage them to do so. Things that will help you do this. Single responsibility principle, right? That single black box was split into 2 lambdas and a queue, and they all did one thing. There was a lambda that took a sample. I don't know how that works on a cannery factory. Maybe they activate a different conveyor belt. Who knows? But that's all it does. It just takes a sample when it responds to that random sampling event. And then the other lambda that processes the results and says it's a pass or a fail, right? That's all it does. It figures out whether the results are a pass or a fail. It is very simple architecture. It's easy to understand, and everybody can understand it, which is the whole point. We want people to understand. We want people to go, oh, can I add this particular component? What's the impact of this particular feature or change to the system? And if they understand the whole system, they're going to be able to have more of a meaningful discussion with you about that. Readability and discoverability. I mentioned earlier in the talk, new devs. New devs are going to understand this a lot quicker than if I just did that black box outside, or maybe the event bridge and the step function, right? Having all the individual components is going to be way easier to understand and get them up to speed. And that's what we want, right? We don't want to have to spend a month teaching the new dev all the different parts of the system. We're going to go, hey, we need to make this change to Lambda XYZ. Go make that change, and they can go do it without any other involvement. So it's a really great way of onboarding people quick and everyone getting up to speed and everyone understanding the system. And the last thing, I've kind of already touched on this, opportunities to enhance your workflow, right? You're not always going to see everything. Just because you're the architect doesn't mean you always know best. Just because you're the senior dev or the tech lead, just because you're the PO doesn't mean you know the best workflow here. By having an architecture that everybody understands, you can all work together and spot opportunities to improve the workflow, to enhance the workflow, to add new business cases and value to that workflow. And that's it, that's me. So thank you very much for coming to my talk, and question time. Sorry.
No. Thank you very much, Trent. So it's not only about making inclusive software for your customers, it's about making inclusive systems so that you can basically communicate better with the team of people that you're working with, all the way through from exec to your junior developer.
Absolutely.
Very good, thank you. Now we're going to open the floor up for some Q&As. Has anyone got a question? Just up the front.
Possibly a loaded question. Have you have you heard of the C4 model of architecture diagrams?
Recently, yes.
Okay, yeah.
Yeah, very similar. I considered adding that to this talk, and you could, if we look at, say, this particular model, you could probably apply that here and say the two big black boxes are one level of the C4, and then you drill down another level and you get a view of the event bridge and the step function and the database, and then another level and you get the internals of the step function, and that would apply there. But yeah, organically came to the same conclusions apparently. I only discovered it in the last couple of months.
You've reinvented it perfectly. We discovered it ourselves about a year ago.
Oh, nice. Yeah, how's it working for you?
It's brilliant. Yeah.
Nice, excellent.
It basically what you showed there, it really opens up the magic black box.
Yep.
More people can understand the system. And
great.
Once you do that, more people can go, oh, hang on, actually, that's a bit crap.
Yeah. Yeah, it leads to an improved system, though, when they say that, right? So, yeah, it's good. Cool.
Thank you.
Any more questions?
Any more questions?
Another one at the front there.
Have you got any advice for people who are reviewing someone else's architecture diagram? Any sort of red flags to look out for and that sort of thing?
Oh, yeah, that's a good one. No boxes. Yeah, look, I can't think of anything off the top. I've not done a lot of reviews, right? I tend to either pick something up and try and figure out what's going on, or I'll be building the diagram myself. I guess the only thing I would perhaps consider when doing a review is maybe build it yourself, do the diagram yourself and see what the differences are, and make sure that you have actually captured all the aspects of the system. Might be a good way of doing it. But yeah, I've never done reviews before, so that's purely guesswork, unfortunately.
Any more questions?
Are there any particular tools that you found sort of helpful or useful in terms of your architecture diagrams?
Yeah, look, I mean, there's definitely tools out there that will generate a lot of this stuff for you. There was, I can't remember the name of it, there was a recent one that works really well with ARM templates and the Azure system. I'm not sure if there's equivalent for AWS. These particular the big real world diagram, I did that in, sorry, I just realised I'm not on the screen, it's there. The big real world diagram, I did that in Visio. It has all the nice icons and everything else to work with whatever platform you're using. But Draw.io as well, free, open source, has same set of pictures and diagrams and everything else. And you can sync it to Dropbox and OneDrive and all the rest, and they're really useful tools.
Lucid?
I haven't used Lucid, but I do know of Lucid. Yeah. They're the most tools I know about.